want to dive into attracting particles to the surface of an object because it seems like it would be rather easy, but it's actually a lot more complex and convoluted than you would initially think. So let's take a look here. This project file is going to be available on Patreon, so if you're interested in that, I have a bunch of different setups in here that you can go over that all achieve the same thing, but do it in slightly different ways and give you different type of results here. So if I press play here, we just have some points being spawned on an object. They're being brought towards the center or towards the surface of this object, and they are stopping when they hit that object. So let's kind of go over how this works and how the kind of the pitfalls of it before we actually dive into recreating it with like a pig head or something. So let's drop down a geometry node and let's drop down a sphere. Let's crank up the scale here. Just going to turn off those primitive numbers. We'll need those in a minute. But I'm going to crank up the scale there. I'm also going to drop down a grid. And this grid I want to be just simply 3 rows by 3 columns. And that's going to give us 4 different primitives here. So let's drop down a pop net, and let's wire that grid into the second input, the sphere into the first, and let's dive in. Let's set our display flag there. So with our pop source here, let's just drag that up. Let's come and disable the guides. And I only want to just create some points on the first frame. So let's disable this constant activation. Let's set this impulse activation equal to an expression, so $ff is equals to 1, and that'll just make sure that we only spawn particles on the first frame, and we can spawn in like 1,000 or whatever we want. So now if I press play, you see we only have particles being spawned on the first frame, and let's go ahead and press D and just change this background to dark, and let's disable our grid as well so we can see a little bit easier. You can see no particles are going to be being spawned after the first frame there. So let's attract them to the surface of our grid. So we'll drop down a pop attract, and we'll wire this in. And in this attraction type, we can do position. We can also do surface points. And by default, this is actually literally going to bring them towards the points on the surface, or the actual points of the geometry, which is maybe not necessarily what we want, but we'll take a look at how we can change that as well. So in this geometry source, let's set this to use second context geometry. And I'm going to drop down a pop collision detect node as well, just so that we can stop these points once they actually hit our grid. So we'll do collision target is second context geometry again, and we'll leave this colored hits on, but let's set this response to stop. And if I press play, you can see that these points are all being brought towards one kind of point in space. And if I jump back out of here and I template our grid, you can see that that is this corner of our grid. And if I actually take a look at our grid, turn on our point number and our primitive numbers, that is 0.0 of primitive 0 on our grid. And that's important because if we take a look back at our pop net here, we come to this pop attract, you can see that we have this primitive 0 and then UV coordinates here of 0, 0, 0. And that essentially is the target position. So our target primitive, if I actually hover over this, you can see that the parameter is called goal prim. That's where it's actually going to be, what point is going to be, what primitive the point is going to be attracted to. And you can randomize that as well. We'll go over that as well. And then this is going to be the UV coordinates of that primitive. So what position on that primitive the points are going to be attracted to. That makes more sense here if we toggle this vex expression, and we can come over to this little drop down and we have this pass through option. And we can take this. Now it needs an integer, so we're going to use a floor node, and that's just going to round down, or not a floor node, but a floor expression. That's going to round down whatever value that we have. So if it's set to like 2.999, it's going to round down to 2 instead of rounding it up to 3, and it always goes to an integer. So we can use a fit 01, so a fit from 0 to 1, because the random function, if we pipe that in, is going to give us value from 0 to 1, and we'll just randomize based off of the point number, or PT num. We'll put that from 0 to 4, not 0 to 3, because remember, a value of 3.99 will round down to 3 instead of 4, rounding up to 4, and we only have 3 primitives, so it goes from 0 to 1 to 2 to 3. So that's how the primitive numbers worked if you paid attention to that. But once we have that, we can just press play, and you can see that they're now being split into different places. And if we take a look at this, and let me actually pop this out. If I press Alt-E, that kind of gives you a bigger look at what this is actually set up to. And if I take a look at this, you can see that it's being brought to these individual points, and that's because the UV coordinates are set to 0, 0. And we can change that if we jump back into our pop attract node. We set this UV to 0.5, 0.5, 0.5, and I reset this and press play. Now they're being brought to different points. And if I jump back out of our grid here, you can see they're actually being brought towards the center of each one of these primitives. So that's what I mean when it's going to what primitive, what your goal primitive is, and then what your UV coordinate space is of that primitive. That's going to determine where it's placed at on each one of these primitives. So we could move these over if we wanted to move them over just further towards the edge, away from the origin. We could set this to 0.75 and 0.75. And if we just replay that, now they're being brought just a little bit further over towards the edge of the primitive, or the diagonal corner of our origin point, which was right here, 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 and here. So we can take this a step further. I'm going to stop this video here though. Let's make this a second part because I'm going to actually get into this a little bit deeper. We're going to cover a couple of different ways to attract points to the surface and just some different methods that you can use to do this, because the different methods that you use can give you some different results, and some of them work better than others. So we'll take a look at all that in the next video. So I do have a bunch of other videos on my channel. If you want to learn more about Houdini, make sure to check those videos out. But anyways, thank you guys for watching and have a good day.